So hello friends, welcome back to our channel Concept with Clarity 1. In this lecture, okay, we'll try to discuss about the KMaps. Okay, so why KMaps? In the previous lecture we have studied about different Boolean postulates, and we have applied how to implement, like how to apply to the Boolean functions, the Boolean postulates to the Boolean functions, and our ultimate goal was to minimize the number of variables being used in the overall design, right? So what happens if I reduce the number of variables or the product terms or number of gates in that sense? Okay, so what happens if I reduce the number of gates? Then the overall cost of the system gets reduced, speed of the system gets increased, okay, power consumption get reduced, okay, so packing density will be increased and all. Okay, so I have so many advantages when I minimize the Boolean function, right? So what we can do is applying the Boolean postulates, okay, is like if your number of gates are lesser, then you can go for the applying Boolean postulates and all. Okay, if the number of input variables are increasing, okay, then we use KMaps. Okay, then we use KMaps, okay, KMap technique, mapping technique, okay, to reduce the number of variables in the given Boolean function. Okay, so and also this is only just by using one step. Okay, by using one step, one simple KMap, by using only one step we can get the complete minimized answer. Okay, so here I can have a 2 variable KMap, 3 variable KMap, and 4 variable KMap, 5 variable KMap also. Okay, we can go up to 5 variable KMap. Okay, 2 variable, 3 variable KMap, okay, 4 variable KMap, okay, 5 variable also. We'll try to discuss this one also. Then what we do, up to 5 variable is okay with the KMaps, and then like if the number of inputs are increasing, then we use other methods, okay, tabular method to minimize the Boolean function, right? So we'll start our discussion with the 2 variable KMap. Okay, 2 variable KMap, 2 variable KMap. Okay, what is a 2 variable KMap is, you see here, if the number of inputs are 2, number of inputs are 2, okay, and for each and every output you need to have one KMap, okay, and number of outputs are 1, okay, number of inputs are 2, number of outputs are 1. Okay, so a KMap is denoted like this. Let us say inputs are x and y, okay, in the vertical direction this will be x bar and this is x, okay, this is y bar and this is y. Okay, now what are these cells? For suppose x and y are my inputs, then I can have 0 0 0 1 1 0 1 1 is the combination, right? So like x bar y bar, x bar y, x y bar and x y. Okay, so same thing, this particular cell represents x bar dot y bar, okay, and this particular cell represents, this is x bar y. You can see here the corresponding, this is x bar and this is horizontal is y. Okay, this is x y bar and this is x y. What you will write? Whatever the output f is equals to, let us say I will have 1 here, 0 0 1 here, like this. Okay, so wherever you have a 1, here I have x bar y bar, that means I will put a 1 there. Okay, right. Okay, now you see here, simply for suppose f is equals to x bar y bar plus x y plus x y bar. Let us say minimize, we have to minimize. Okay, and other thing is in KMaps, okay, in KMaps the equation or the Boolean function should be in standard form, in standard form or canonical form only. Okay. So what is this standard form or the canonical form? Is nothing but for suppose if I take this particular Boolean function f is equals to x bar, y bar, xy and xy bar. Here in the last class, like I told you, number of inputs equal to 2. What are those? X and y, right? Number of outputs equal to 1, that is equal to f. Okay. So I have three product terms. One is x bar, y bar, one is xy and the one is x y bar. Okay. So in these three product terms, for suppose my inputs are x and y. The first product term I have the combination of x and y. In the second product term I have the combination of x and y, and in the third product also I have the combination of x and y in the form of normal x or x bar, okay, or y bar. Okay. So in each and every product term, if all the inputs are available, okay, if all the inputs are available, then it is called, then that particular Boolean function is said to be in the standard form. Okay, in the standard form. For suppose if I have equation like this, f is equals to x y bar plus x y bar z plus xy plus x bar z, something like this. Okay. So this is not in canonical form, not a standard Boolean function. Okay. So this is only a Boolean function, it is not in standard form or canonical form. For suppose if I write the same thing as x y bar z plus x y z plus x bar y bar z, something. Okay. So in each and every product term, if all x y z are repeating, then that particular equation is called as standard form or canonical form. Okay. In KMaps we use the standard form equations only. Okay. Now let us try to apply this one. F is equals to, let us say, x bar y bar plus x bar y plus xy. Okay. Minimize using KMap. Minimize using KMap. Okay. First of all, here I didn't tell any KMap, which KMap to be used. Okay. How to identify which KMap to be used is by depending on the number of inputs. Okay. Number of inputs is equals to 2. Okay. What are those? X and y, right? So if the number of inputs are 2, if the number of inputs are 2, then I shall use two variable KMap. Two variable KMap. Okay. So you see here. So what is the two variable KMap? I already have this one. We have seen, right? What are my inputs? X and y. X and y, right? So x bar and x and y bar and y. Okay. Now let us try to plot this one. Okay. Then we will try to map. Okay. Now you see here, first I have x bar y bar. So x bar y bar, the combination is here, x bar y bar. Okay. Similarly I have x bar y. X bar y is nothing but a 1 here. Okay. Wherever you have this one, you put it as a 1. Okay. And xy equal to 1. Okay. See, in two variable KMap, okay, in two variable KMap, possible mapping is a pair only, is a pair. So what is a pair? Pair is two ones adjacent to each other, adjacent to each other, right? So you see here, two ones adjacent to each other. I have two ones here adjacent to each other, so this will be pair number 1. Okay. Now I have another one, this is another pair. Okay. You can ask, this one is already mapped with this one, still I can map it. Okay. Still I can map it, and I will map it as pair number 2. Okay. Our aim in mapping a KMap is always we should see that all the ones are being mapped to the others. Okay. all the ones should participate in the mapping. Okay, now you see here, what is this one? The answer, like I told you, in one step we will be getting the answer. Okay, for pair 1. Okay, for pair 1. Now you see here, now you see the magic. Okay, now you see here, pair 1 is this one, right? You write the combination. Okay, I will write the answer. First you write x and y, my inputs. Okay, so what is this combination? X bar and y bar. This is x bar and y bar. I will write 0 0. Okay, and this one is x bar y. X bar means 0, y means I will write 1. Okay, now in this one, if you have 0 and 1, just you cross it. Okay, and this is 0 and 0. If all are 0, then my answer is x bar here. Okay, therefore for pair 1, f is equals to x bar plus. Now for pair 2 we will see. For pair 2, okay, so what is my pair 2? My pair 2, you see here, I have the vertical one, right? So for pair 2, again I will write x and y, right? So what is the combination? One is x bar y and second one is xy. Okay, one is x bar y and the second one was xy. If zeros and ones are there, you just cross it. Okay, if everything is 1, then you write simply y. Okay, therefore for pair 1 the answer was x bar, for pair 2 the answer is y. Therefore f is equals to x bar plus y. You see here, initially I had 3 product terms. Okay, x bar y and xy. Here we didn't use any Boolean postulates. Directly by using a simple KMap, we have minimized it to x bar plus y. Okay, now let us try to see another example for your convenience. Okay, so f is equals to x bar y plus xy bar plus xy. Okay, now we shall see this one. Okay, first what you will do, first you need to know which KMap to be used. Okay, this is for a practice. Okay, 2 inputs, so 2 variable KMap. Okay, 2 variable KMap. Directly I will draw here 2 variable KMap. First thing you need to do is you need to draw the KMap. Okay, you need to know how to draw the KMap. Okay, so this is, you see, x and y, right? So this is x bar x and y bar y, right? Now x bar y is a 1 here and xy bar is a 1 here and xy is a 1 here. Now you please tell me what are the mappings here. I have a pair mapping here, this is 1, okay, and I have a pair mapping here, this is 2. Okay, so 1 and 2 is your wish. Okay, first you can take this as 1 and the horizontal one, vertical as 1 and the horizontal as 2. So that is up to you. Okay, only thing what we concentrate is on the answer. Okay, so for pair 1, okay, first to, you know, for your convenience we are doing this much process. Directly also we can tell the answer just by looking at the common terms. Okay, we can tell, I will tell you, you know, in the coming this thing, right? So for pair 1, first you write this one xy, right? So for pair 1, you see here the combination is xy bar, that means 1 0, and the second one is xy 1 1, right? So what is the answer? 0 and 1 is there, I will simply cross it. So x is the answer here. For pair 2, right? So x y, for pair 2 this is x bar y and x y. So this will be this thing and only y is the answer. Okay, therefore f is equals to addition of pair 1 and pair 2, that is equals to x plus y is the answer. Okay, so I hope you have understood the concept of 2 variable KMap in which a pair mapping is being used. Okay, so and how to plot this one into the KMap and all. Okay, fine. We can also have like this also. So one step further, you see here this KMap x y, x bar x, y bar y. Okay, So I can have this number this as 0, 1, 2, 3. Okay. So in the sum of the products form, SOP form, this is sigma m of, let us say 0, 1, 2, 0, 1, 2. Okay. Directly you can have this one also, 0, 1, 2. How you will write? How you will write is, this is 0, 1, 2. So wherever you have wherever the SOP, okay, some of the product terms are given, there you put a 1 at 0, 1, 2. Okay. Now again you write this as pair number 1 and this as pair number 2. Therefore f is equals to, okay, what is pair number 1? You can just solve this one, x bar plus y bar. F is equals to x bar plus y bar. Okay. Right, you can simply see what are the common terms here. Okay, x bar is common in both, but y is changing from y bar and y. You simply discard y. So whatever common, it is x bar is common. In this one you see x is varying, x bar and x, but y is common, y bar is common. So y bar. Okay, so you can go for the traditional method, or by simply looking at the KMap you can derive this one. Okay, so and also how to know the number of inputs being used in the KMap is by the highest number which is given in the Boolean function, okay, in the SOP form. So 2, 0, 1, 2, 3. Okay, that means up to 0, 1, 2, 3, 4, up to 4 means you have two variables, 0, 0, 0, 1, 1, 0 and 1, 1, right. So this is how a two variable KMap is solved. Okay, so I hope you have understood the concept of a two variable KMap. Now if you have understood the concept, then please like the video, share it to your friends and subscribe the channel. And in the next video we are going to see about 3 variable KMap and 4 variable and 5 variable KMaps as well. Okay, thank you for watching.